All right, everybody, welcome back. Ready for another deep dive. Today, it's all about physics, a classic problem that honestly still kind of bends my brain a little bit. The monkey and hunter thought experiment.
Ah, a classic.
So imagine this. You've got a hunter aiming right at a monkey hanging from a tree.
Okay, I'm picturing it.
But here's the thing. The monkey, smart little guy, lets go of the branch the exact moment the hunter fires.
Sneaky monkey.
Right. So where should the hunter aim to hit the monkey as it's falling?
Yeah.
Directly at it, above it, below.
It's a question that trips a lot of people up.
Totally. And to help us break it all down, we're going to use a simulation from Open Educational Resources, Open Source Physics at Singapore.
Yeah.
We've got this awesome JavaScript model that lets us actually see what happens.
Visualizations like that are so helpful, way better than just trying to picture it in your head.
Big time. So in this simulation, they use two cannons facing each other, kind of like our hunter and monkey, right? And they can fire projectiles at all sorts of different speeds.
Ah,
The thing is, no matter how fast or slow they fire, the projectiles always collide in midair. It's wild.
that's the key takeaway here. It's all about gravity and how it affects everything equally. Doesn't matter how heavy something is or how fast it's moving sideways.
So the projectiles aren't like magnetically drawn to each other or something. It's just that gravity's pulling them down at the exact same rate.
Exactly. Imagine if there was no gravity. Those projectiles would just fly in straight lines and smack right into each other, because that's how they're aimed, right?
Right, makes sense.
Gravity just adds the same downward motion to both of them, so they still meet at the same point.
So even though the monkey is falling, to the hunter, it's almost like aiming at a stationary target because the dart is falling too.
You got it. It's one of those things that seems totally counterintuitive, but that's physics for you. It all comes back to Newton's first law of motion, too. An object in motion wants to stay in motion unless something acts on it.
And that something is gravity. But it's acting on both the dart and the monkey equally. It's kind of like,
Oh.
okay, think of tossing a ball straight up in the air while you're on a moving train.
Mm.
That ball doesn't suddenly fly backwards, right?
A perfect example.
It goes straight up and down relative to you, even though the train's moving forward.
Exactly. The ball's horizontal motion is the same as the train's, just like our monkey and dart. Same horizontal speeds and same downward pull from gravity.
So in our simplified model here, to hit that falling monkey, the hunter just aims straight on. My mind is a little blown, not gonna lie.
It's definitely surprising,
Yeah.
but the physics backs it up. Now, of course, out in the real world, it's not quite that simple. Things get a bit more
Complicated.
complicated. So you're telling me the hunter shouldn't aim directly at the monkey then?
Well, remember, our simulation, it keeps things pretty simple. Out in the real world, you've got all kinds of things going on. Air resistance, for one. It can really mess with a projectile's path. Air resistance, yeah. I kind of remember that term from like way back in high school physics class. But remind me, what does that even mean?
Basically, it's the force that air pushes back on anything that tries to move through it. Stick your hand out a car window when you're driving, and you can feel it, right?
Yeah, totally.
And the faster you go, the stronger that push gets.
Okay, so back to our hunter. How does air resistance mess things up for him and his dart?
Well, think about it. The air is going to be pushing against that dart the whole time, slowing it down. And that can make it, not travel in a perfectly straight line.
Ah, I see.
And how much the air resistance affects things. Well, it depends on a bunch of factors, like how big is the dart, what shape is it windy out, even how humid it is, believe it or not.
So even though aiming straight on works perfectly in our nice little simulation, a real-life hunter would have a lot more to think about.
Exactly. Wind speed, how heavy the dart is, how it's designed, even how thick the air is that day. It's a
Yeah.
much trickier problem all of a sudden.
So the monkey and hunter, it's a great way to show us the basic idea. But the real world always likes to throw in some curveballs, right?
And that's what makes physics so cool. It's not just about memorizing a bunch of equations from a textbook. It's about understanding how those rules play out all around us.
Totally. Okay, so we started with a simple model, then added air resistance. Now I'm curious, are there other things that could mess with our hunter's aim too?
Oh, yeah, definitely. Let's say our hunter, maybe he's driving after this monkey in a Jeep, speeding through the jungle or something.
Okay, I like where this is going.
And to make things even more interesting, let's say there's some wind blowing, and the
Yeah.
branch the monkey is hanging from is swaying back and forth.
Whoa, hold on. Now we've got a hunter who's moving
Mm.
and a target that's moving in like multiple directions at once. This is getting pretty intense.
Now things are getting interesting, right? Because to hit that monkey now, Our hunter can't just rely on that basic aim directly idea. He's got to think about how he's moving, how the monkey's moving, and how the branch is moving too.
So it's like that ball on the train analogy again. But now the train tracks are bumpy and all over the place, too.
Perfect way to put it. To figure this out, the hunter needs to understand relative motion. How fast is the jeep going? Which way is the wind blowing the branch? How high is the monkey? How fast is it falling? All of that.
Our hunter is going to need to be part physicist, part sharpshooter to pull this off. Are there even equations that could help him out here, or is it just pure instinct at this point?
Oh, there are definitely equations for relative motion, yeah. But out in the jungle, our hunter would need a good dose of instinct and experience, too. He's got to see all those different variables and adjust his aim on the fly.
My head is spinning. It's amazing how something that seems like a simple physics problem can get so complicated once you start making it more realistic.
That's the beauty of it, right? But it also shows us how physics works in the real world. Start with a basic principle and then keep adding more layers until you get the whole picture.
So let me get this straight. Even with a Jeep, a swaying tree, air resistance, and all this relative motion stuff, a good enough hunter could still make that shot. That's pretty wild.
Absolutely. It all goes back to understanding the physics. On the surface, it looks totally chaotic, but underneath it all, there's a pattern to it, a set of rules that determine how everything interacts.
So it's like hidden order beneath the randomness. And physics is like the key to unlocking it all.
Exactly. And the better we understand the tools, the more we can really appreciate how amazing and intricate everything around us is.
I love that. So we started with the monkey and hunter. Seems so simple at first, right? But then we added gravity, air resistance, moving targets. Things got pretty complex.
And what we've seen through all of this is how the same physics applies to so much more than just a hunter and a monkey, right? I mean, think about launching a rocket or predicting the weather or even just like trying to throw a perfect curveball.
Or figuring out how to sink that basketball shot every time.
Exactly. It's all physics, all the time.
It's kind of mind-blowing when you think about it. These same laws of physics, they govern everything, from the tiniest atoms to massive galaxies.
Pretty incredible, right? And for everyone listening out there, think about how you might use this kind of thinking in your own life. Maybe you're trying to, perfect your golf swing or figure out the best way to throw a paper airplane.
Or maybe you just want to win a bet with your friends about whether you can actually catch a dollar bill before it hits the ground.
Yeah.
That classic thing.
Whatever it is, the point is, physics isn't just some boring thing in a textbook, right? It's about understanding the world, how things work, why things move the way they do.
I'm with you there. So next time you see something fall or you're watching that basketball arc through the air, remember the monkey and the hunter. There's a whole lot of physics happening right there.
And who knows, maybe one of you listening will be the one to solve the next big mystery of the universe, right?
And on that note, we'll wrap up our deep dives into the monkey and hunter. Hope you all enjoyed it. Until next time, keep those brains buzzing and keep exploring the world.